students, today's lesson is on representations of functions. So we'll start with a key idea, and that is that a function rule is an equation that describes the relationship between inputs, or independent variables, and outputs, or the dependent variables. So here we have this little picture showing a function rule, y equals 3x. If we put in a -2, if that's the input, the output would be -6, 3 times -2. So let's start by writing a function rule, an equation, for the output, or y, is 5 less than the input. So that would be y equals the input minus 5. Then we can write a function rule for the output, y, is equal to the square of the input. Y equals x squared. For our next example, we'll evaluate a function for a given input. So if our input is 3, we need to find our output. So our output is 2 times 3 plus 5, or 6 plus 5, or 11. All right, so one more key idea, and that is that a function can be represented by an input-output table or by a graph. So I'm showing you both an input-output table and a graph here. Let's go ahead and fill out an input-output table and graph the function of y equals -2x plus 1 with the given inputs of -1, 0, 1, and 2. So we'll fill those in first. -1, 0, 1, and 2. So let's go ahead and evaluate -2 times -1 plus 1. That's 2 plus 1, or 3. So our ordered pair is -1, 3. And then for our next point 0, we have -2 times 0 plus 1, or 1. Our ordered pair is 0, 1. Then we have -2 times 1 plus 1. It's -1 for a point of -1, or sorry, 1, -1. And then our last input is 2. -2 times 2 plus 1. -4 plus 1 is -3. So we have the point 2, -3. Now we just need to put those on our graph. So we have our point -1, 3, 0, 1, 1, -1, 2, -3. You should use a straight edge for that. For this, I don't have a big one here, so I'm just going to sort of sketch that. But that's what our line will look like, our function, given that those inputs. And here we have a real-life application. So the number of pounds of carbon dioxide produced by a car is 20 times the number of gallons of gasoline used by the car. Write a function that describes the relationship between G and P. So we see that the pounds, or P, is equal to 20 times the number of gallons. Okay, so that's going to be our function, is 20G. So given an input of, let's just do 0, 1, 2, and 3 here. So 20 times 0 is 0. So we have the point 0, 0 on the graph. Then we have 20 times 1. So our output is 20. So the point 1, 20 is part of our graph. 20 times 2 is 40, so we're going to graph 2, 40, and 20 times 3 is 60, so we'll do 3, 60. Okay, so we need to fill out our graph here, our axes. Move this just a little bit. Okay, so this is going to be our input will be gallons, and typically that's on the x-axis, of course, and then our output is our carbon dioxide. Okay, and then let's see, we're only going to graph up to 3, so let's just do every other here. So here's 1, 2, 3. Put a 4 on there too, just for fun. And then let's see, counting up, every 2 lines, let's make that a 10. So every space would technically be 5. So 10, 20, 30, 40, 50, 60. Okay, so we have the 0.00, we have the 0.1, 20, 2, 40, 3, 60. So again, use a straight edge for this, but I'm just going to kind of sketch it in here. That's going to be what our function looks like. All right, that's it. Go ahead and try a few on your own. I'll see you soon.